NaxTo Cell is a post-processor integrated in Microsoft Excel. It works making requests or queries to a finite element results file and extracting all the relevant information inside the file, without the need to open any other post-processor. Let's go with an easy example to see what is the philosophy of NaxTo Cell, what advantages it offers and how to work with it. Once installed NaxTo Cell, you will see that a new category of functions in Excel named NaxTo Cell. NaxTo Cell functions can be accessed in the drop-down list and they work exactly the same way than the other common functions in Excel. The only difference is that they getting results and other information from binary files like Opus2, H3D, ODB, RST generated with Abacus, ANSYS, Nastran and Optostruct. The information extracted can be results, information from elements, nodes, coordinate systems, components, increments, parts, sections, load cases, and also incorporates generation of envelopes, freebodies, etc. As we can see when we scroll down the list, all these NaxTo Cell functions names start with N2C. Working with NaxTo Cell is very easy since all functions work exactly the same way and with the same philosophy as Excel functions work. All these functions return tables of information such as list of elements, nodes, coordinate systems of your file, etc. and of course, they also return results in the selected format. This allows you to create sheets like the one we can see now. Let's see how NaxTo Cell works with an example. It shows a model with bolts, that calculates a safety margin for the bolts by this simple formulation. NaxTo Cell allows you to create templates so that your whole team always can work in the same way, harmonizing processes and avoiding errors or maintenance of other external tools such as macros. You can prepare a sheet that can be fed with different results files, so if any changes in your model you can easily recalculate results by trying, for example, different materials, thicknesses, and so on. To get the list of load cases for the model, just select the N2 load cases function, and once the function wizard opens, select the file path and the rest of the requested fields. Clicking the OK button automatically displays the list. Once the sheet is prepared with all the model information, the results are obtained. We are entering a little more into detail with two examples of application of results use. First example is prepared to calculate the bolts by using the results of the forces of a list of elements in C bars. To get the results it must be selected the N2C results function, and fill in the indicated arguments. Some are mandatory, for example, the file from which results are taken, the type of result, the list of elements and components you want. And then are some other optional arguments that can be left blank if not needed. There is a help sheet for the NaxTo Cell functions that explains what to indicate in each field. Once you have filled in all the required fields, you click on the OK and it automatically will display the table with all the results. Since N2C results is an Excel function, if you change any of its arguments, the table will be recalculated. For the next example, a table has been prepared in an usual working format. The results are taken from a first file named design2. If for whatever reason, you need to rerun the model again because for instance, you have changed the thicknesses, and you want to obtain again the safety margins of the bolts, you just need to change the cell of the model path from file design2 to file design1. Automatically, the cells that reference the model will be recalculated. As you can see on the screen, all the values have been updated. Apart from getting all the information from the results files, there are some interesting functions in NaxTo Cell like N2C plot contour. N2C plot contour plots whatever results you want from Excel on the 3D model. To prepare this example, we have extracted results in von Mises of a list of elements in C tetras for load cases 1 and 4. We are generating a new result and we want to plot it on the 3D model. Once the results of load case 1 and load case 4 are obtained, our new result is generated from product of load case 1 by 0.7 plus load case 4 multiplied by 0.3. Then, this newly created load case with its results is represented in the 3D model window easily as shown. Again, if you would like to plot results from a different file, just change the file path and the model plotted in the 3D window will be also automatically recalculated. This allows you to change the data in Excel and see in the 3D window the results obtained. In summary, with NaxTo Cell you have the power to access to results from MS Excel with no need for other post-processor, preparing Excel sheets to automate analysis, that you can reuse as templates, avoiding macros and saving a lot of time while reducing errors. Here ends the brief introduction to NaxTo Cell. We hope you enjoyed it.